In this video, we're going to be talking about electrolytic cells. In the last video, we talked about electrochemical cells, and their main thing was that they were a spontaneous chemical reaction that produced electric currents. Electrolytic cells are not spontaneous chemical reactions. If you have a redox reaction that does not occur spontaneously, you can actually force it to take place by supplying energy with an externally applied electric current. So in an electrolytic cell, we use an electric current to produce a chemical reaction. That's one of the big differences between the two types of cells. Electrochemical cells use a chemical reaction to produce electricity. Electrolytic cells use electricity to produce a chemical reaction. So next, let's look at some of the basic concepts of electrolytic cells. So they still have electrodes. There's still a cathode. But this is one of the big differences that leads to a lot of confusion between these two cells. The cathode is now the negative electrode. And you just need to kind of know that, and you need to know whether you're dealing with an electrolytic or electrochemical cell when you start labeling these things, or you can get some questions wrong. The good news is that reduction still takes place here. So you can remember red cat. Reduction at the cathode. It just changes its sign. It's now negative. We'll talk about why in a minute. In electrolytic cells, positive ions become reduced at the cathode. And in electrolytic cells, this cathode tends to be an object. It doesn't have to be, but on the reader's exam, it's usually an object that we are plating metal on top of. The anode is the positive electrode. Note the sign has changed again. The anode was negative in an electrochemical cell. It is now the positive electrode in the electrolytic cell. But oxidation still takes place here, so you can remember anox. In an electrolytic cell, negative ions are oxidized at the anode, and it tends to be a metal bar. Okay, so let's draw how an electrolytic cell looks. So if you remember, electrochemical cell had two half cells, two separate containers. Electrolytic cells only have one. They're still filled with an electrolyte solution, some sort of aqueous salt solution. And we have a electrode in here, the bar. So let's have a silver bar, and we'll have an object. We'll have a fork. So maybe we're making a silver-plated fork. Now, this is a non-spontaneous reaction, so we need to use a battery to make this reaction happen. And the battery is hooked up to the metal bar and the fork with a wire. Okay, so my metal bar is my anode, and that's positive. Electrons from the battery will flow out of the battery and into my cathode, my fork here, and make it more negative over time. So one of the reasons for the sign change is due to this battery. So you can, if you don't remember the switch for the sign changes, in electrolytic cells, you could just follow the terminals of the battery. So the positive end of the battery is hooked up to the bar. That's how I know my anode is now positive. And my cathode, the object, is hooked up to the negative terminal of the battery. So that's how I know it's negative. Okay, so my bar here is the anode. Remember, oxidation happens at the anode. Remember anox. And in oxidation, electrons are lost. Lose electrons, oxidation, or LEO. So the silver atoms are turning into silver ions by losing one electron from this bar here. So the atoms of the bar disintegrate into silver ions in solution, and it liberates or frees an electron, which will travel up the bar, over the wire, and into the battery. Now, because the electrons from the battery have flown into my cathode, they are making this cathode more negative, and they're going to attract the positive ions from solution here. So the silver ions that are in this solution are going to migrate to this cathode and be reduced to silver atoms on the surface of this fork. So if this fork was made out of, say, steel, over time, being in this electrolytic cell, it's going to be plated with a thin layer of silver. So that's a reduction. We're gaining electrons at the cathode. So remember red, cat, reduction at the cathode. And here's the half reaction for what just happened. The silver ion from solution gained an electron that it got from the battery and reduced it to a silver atom on the surface of the fork. So the longer this fork sits in this solution, the more and more silver will get plated on top of it. And this is how you get silver plated silverware, or you can make jewelry this way. You can put chrome on bumpers of cars or other metal parts that get chromed, are all made with electrolytic cells. So in summary here, an electrolytic cell is a non-spontaneous reaction, but you can force it to react with energy added from batteries. And they convert electrical energy into chemical energy, unlike an electrochemical cell, which converted chemical energy into electrical energy. So it's kind of the reverse. So you need to know all the parts of an electrolytic cell. You need to be able to determine the anode from the cathode, the charges of the electrodes. Remember, the anode is positive because it's attached to the positive end of the battery, and the cathode, or the object that we're plating, is negative because it's attached to the negative end of the battery. You also need to know where oxidation and reduction take place. If we remember our phrase, anox, red cat, it's still the same for both types of cells, so that's helpful. And you need to know what happens to the electrodes over time. Just like in electrochemical cells, over enough time operating, the anode is going to disintegrate as it loses electrons and ions to solution. And the cathode is going to get bigger as the positive ions in solution from the anode are going to get plated or reduced to solid atoms on the surface. So that's electrolytic cells, very easily to confuse with electrochemical cells. There's no way around this other than just studying this and memorizing the parts and doing enough practice problems where you label these things and answer the questions. And we'll tackle a lot of that in class. But if you have any questions or if you're stuck in anything here, please let me know.